and I'll show another one.
I don't know what happened.
So
That was weird.
what we're trying to get at here is we're trying to look at mechanisms that will allow us to gain insight into a model as it's running. And often you'll use multiple lenses for this, okay? Not just a single type of output, but multiple outputs for a given model. And these outputs will summarize different aspects of the model state that may be insightful. So what we're going to do next here is we are going to put in place some additional types of data collection for the same model that will provide us additional understanding of what's happening at an individual level and at a global level. Okay? So the first thing I want to do, and this is to build some understanding, is I would like to show this graph of prevalence of infection. I would like to show a different graph for each of a low-income and a high-income population. Okay, and I'm going to create a model, or excuse me, create a parameter called income classification threshold. Okay, and the idea would be anyone below this income will be considered low income, low SES. Anyone above will be considered high income. Okay, and it's going to be 500. Excuse me, it's going to be 300. Okay. In order to pick this income threshold, actually, I would like to do one statistic to pick a savvy value for it. Ladies and gentlemen, I would like to challenge you. How am I going to compute how would I compute an income such that half the population is less than that and half the population has an income greater than that? What can we do?
Using if statements?
Okay, possibly we could do something with this statement. I would like to propose that we create a histogram of people's incomes. We'll divide them into bins, okay? And we'll find where the median income is. Now, suppose that the latest version of AnyLogic has incorporated a median indicator. Think in the statistics area, which I've told them for years is deeply needed instead of just average. They need a median. From what I understand, they've finally done that. I've yet to verify that. But what I would like to do is put in place a histogram. So we're going to have a histogram, and the quantity income, does it change in this model? No, it's a fixed parameter. So we're going to have a one-time event to draw it. So I'd like to go create a histogram and a one-time event. So what do we need to draw in? Does anyone remember to create a histogram? What do we need to draw in?
That is the histogram.
Yeah, exactly. We need to go to the palette, we need to go to analysis, and we need to go to two things, histogram and histogram data. We need them both, okay? We need them both. Thank you, Kurt. Much appreciated. Okay, so ladies and gentlemen, here it's going to be our histogram, and we're going to call it income histogram. Income histogram. Okay? And we'll show both the cumulative distribution function and the probability mass function. Okay? Probability density function. Next, we're going to go and put in place a histogram data object on which this will depend, ladies and gentlemen. Are we okay with that? Okay. So, ladies and gentlemen, let us now go put in place a histogram data object called income histogram data. Income histogram data. Data. Boom. Are we ready for this? Okay, now you'll notice that it has calculate percentiles here, and I'm forgetting the exact semantics of that, but we'll check calculate percentiles there. Okay? And we could set a variety of things in the number of bins. Okay? So here's the income histogram data. Here's the income histogram. What do we need to do in the income histogram to have it know about and use the income histogram data? Does anyone remember?
Add data?
Yeah, we need to add histogram data. And we will say income. And the histogram, where it says histogram, confusingly, what do we need to put in there instead? Where it says histogram in the data area.
The name of the thing.
The name of the histogram data. Histogram data. Boom. There we go. Ladies and gentlemen. Okay, we're much of the way done. I'm going to show mean too in this. Yeah.
What is PDF and CDF?
That's a probability density function and the cumulative density function.
Which data did you go to?
Sorry, this data. So I dragged in a histogram data object, and I named that income histogram data. And I did check calculate percentiles there, but otherwise left it and give it a name, but otherwise left it unchanged. And then I did an income histogram. Are we okay with this? Okay. Okay. Ladies and gentlemen, so now we need to populate these. How will we populate these?
Yep.
We're going to populate them at the initial time, reflecting the fact that people's incomes are known at first. We don't have to populate it on an ongoing basis. So how are we going to do that?
Maybe an event.
Yeah, we're going to put in an event, ladies and gentlemen.
Oh, this
And
is
the event will be
you want to draw in a histogram.
populate income histogram.
That becomes your income histogram data.
Okay,
You want
it occurs once.
to put
And
that first-
can anyone remind me, what will the code for this be? What will the code for this be?
Yeah, so we won't let you save that because
Anyone remember?
Something add.
there.
Indeed,
Something
indeed.
is.
Okay,
Don't
and
change the name of it.
okay, there's something. Yeah, you're getting close. What does it need in it? What sort of thing? What sort of thing does it need to go through each person in the population?
Self.
And then you'll put
It
the
needs
percentage.
a.
Self.
Okay,
Self.
there's no self.
That's what's the label.
No self here.
The lights, this line.
It needs it to go through each person in the population in turn. What does it need? It needs a. I'll give you a hint. It is an L, two O's, and a P.
That's an event.
Wait. Strong.
It,
An L, two O's, and a P.
yeah,
Cool.
cool. There's a story with me for that.
Yeah.
Okay, ladies and gentlemen. So as a general rule, we don't actually need to do it here specifically, but we will reset the income histogram data. We'll do income histogram data reset. It's a good habit to be in.
So why does the light bulb say self and
Oh, that's just because you can refer to the event as self if you want to. The event itself can be referred to as self.
But if you said this, what would you be referring to?
me or
What would be what's the
I
me
mean, the
The person?
The-
No, no.
main?
oh I see
It's the
okay.
class that you're in,
Gotcha.
Yeah.
right? So if you want to, if you want the main to be doing the thing, you say this.
Ah,
If you want that event to be doing it, then you have to. There needs to be a name. It's not a Java construct, so it's a construct within AnyLogic. So you need to be able to sort of to like title, who's doing the what, right? Because all of these in agent-based model, all these things are kind of agents, and they're all doing stuff.
And you ask them to do things. You
Yes.
say, population, give me this. Or you
Yeah.
say, the person do that, or main to do that.
So
or
all
the
those
event to do
selfs and thises and stuff, those are kind of like prepositions
mhm.
within the language. You're saying, who's doing this one? You're doing this one. He's doing that one. They are doing that one. Each one of those is a different preposition, points to a different person.
Okay. Great.
Yeah.
Thank you.
Yeah. Good. Okay, so we're going to engage in a loop, not a pool. Okay? Here we go. For person, we're going to call each person in turn person, lowercase person, in this dot population, in the population, for each person in the population. You ready? What are we going to do with that person's data? Into what will we place it? Whither does their data go? Their income?
The histogram.
Into the histogram. So we're going to tell the histogram, add their data. So how do we talk to the histogram? This dot income histogram data. We have to tell it, hey, histogram data, add, okay, there, you got it, add what? What are we going to add to it? Person.income, a person's income. We're cooking with gas, ladies and gentlemen. Okay, great. That's it. Ladies and gentlemen, that's it. Can we run this? What do you think? Can we run it?
Can always run. Yes.
It's always possible.
You can always click the button. That doesn't mean it's always going to run.
Okay, let's build it. Okay, mine is a happy camper, but if yours is not, there's a Krugerian consult available with a capital K. Okay, are we ready to run it? Okay. 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 So where's our where to for art thou histogram? Okay. So it's up here, right? Here we go. Look at these income categories. Ladies and gentlemen, here's our income data. Right? And bizarrely right now it lacks a statement of the median. Gives a mean, but no median yet. Okay. Okay. Here's the cumulative distribution function. Most of them fall within the range to less than $7,000, but that's not telling us much. So let's go modify that a little bit more. So that's our distribution histogram. How can we make it so that that histogram actually shows a defined set of range? How can we do that? Can anyone tell me?
Option list.
Okay, we can actually go to the histogram data and we can tell it something about what the values range is here. Okay. And we can actually tell it the number of bins. So we could ask it, for example, summarize things between 0 and 1,000, for example, and we can have more histograms if we want. We could do 20 histogram bins rather. Okay. Notice it does say calculate percentiles, and I'm wondering if I said low and high both 50%, I wonder if it would actually calculate the median for me. I'm not actually sure, so I'm gonna try that before I recommend it to you. Okay, here we go. I'm gonna go up and click here. Okay. Look at that. Okay, that's interesting. Ladies and gentlemen, do you see what I see? Do you see this? I think those are the upper and lower 50%. Very likely. Okay. So let's go modify this a little bit more. Can we turn on a legend? Yeah, there's a legend. We can have the legend be at the bottom. To have the legend at the bottom, we'll want to drag this up so that we have some space there, and we could drag up the top correspondingly like that. Is that okay? There we go. There we go. Okay. Hey, oh man. There we are. Are we ready? Okay. So I'm going to go check it out. Here we go. Okay, yeah. So it still doesn't give much information on the, yes, look at that. Here's the, you can see in this diagram here, the bottom the bottom area is this, so this must be 50%. So it looks to me it's about 330. Again, it's terrible that it's forcing us to do that. But this is the cumulative distribution function, I think. This one here. I'm not sure about that. Actually. That doesn't make sense. That doesn't make sense.
The other way.
Yeah. Well, I mean, this should go up to. If this is the CDF from this, you'd expect it to be much higher than that, at 50%. Okay, ladies and gentlemen, I just want to be sure of one thing here. Okay. So I'm going to put in place, yes, you could see this seems to show the left side as being, yeah, the CDF color is this. It's interesting. Okay, right. So, pardon me for just a second, and then we'll get going here. Okay, I just want to experiment a little bit more with this, make sure I'm not misleading you on one thing here. Okay, yes, right. Okay, so this does look like the CDF curve here is up here, and so we could tell it, for example, please plot it between certain values, and we could see more clearly where the CDF crosses 50%, right? So we could say plot it from 0, values range from 0 to 10,000, for example, and I could plot this out, and until they get the median in our version here, looks to be like 50%, it crosses right about here, 3,000, looks to me, if that's the CDF. So there's quite a few above that, and then lower group. This is the mean, I think, here. No, that doesn't make sense. I'd expect that to mean to be higher, actually. Yeah.
I guess I don't quite understand that first bin has bigger than 50%.
Yeah.
Yeah, you're right about that. Ooh.
That's the big one.
Okay, that doesn't make sense then. Yeah. Unless this is perhaps labeling the CDF itself. So let's see. Yeah, that first bin is not.
Isn't it because you put 50 for both low and high
There's-
things?
200. It's possible. 250 is the count. 140 of them are between 0 and 500, so that's over half.
Yeah, that's the first bin.
Indeed. Yeah, you're right about that. So why is it that the CDF is
Maybe it's plotted and not according to the percentage scale.
exactly? Let me do copy, and let's go over here, and Kurt, remember you told me, okay, this use text import wizard. Yeah.
I think you probably did a tab or something.
You need a tab, yeah. This guy here. Okay. It's still not that instructive, though.
No, it's
Still saying this is 141, but it's not showing the scale. So yes, I think you're right. I think this must not be the CDF scale.
Yeah.
It must be this. This is probably 100% there.
Yeah.
Something like that. In which case, 50% would be reached somewhere down.
Get 30.
Yeah, somewhere around here, right? It looks around 500, and this would be the mean. Then.
Yeah.
Yeah. Okay.
Yeah, it seems like a bug.
Yeah, or at least it's just leaving it open. Okay, the mean is 2483, which is this one here. Yeah. Okay. So this is the mean. This is probably on a scale where this is 100%.
Yeah.
This is crossing 50%, probably right around here, so it's around 500. So, ladies and gentlemen, in short, let's go back to our parameter that we added, and let's make that income classification threshold be 500. Okay? 500. Okay. Great. Okay, now, what I'd like to do is, for this fractional prevalent infection, I would like to put in place a prevalence among low-income people, that is, those below the threshold and those above. How are we going to do that? How do we have a prevalence for the whole population? How do we do that? Anyone remember? Yeah, we used an average. And where did that average live? In the population. So let's go back to the population. And I'll show you another useful way to do it. Okay, so here's the population. Let's go down to fractional prevalence of infection. And I'd like you to copy that expression. And we're going to go add another one. Just like that. Oh, you know what? You know what, folks? There's actually a duplicate. Do you see that? Do you see that? There's actually a duplicate here.
Oh, cool.
So here, okay? Fractional prevalence of infection among low income. Yeah, I know. Don't get into that. Believe me, it was. Oh, look at that. That's pretty interesting. It was sparing me bugs, Kurt, maybe before you were born. Okay, fractional prevalence of infection among low income. Okay? Are we okay with that? What's the condition here going to be?
Income is more income.
Okay, whose income?
I was just getting ready to enter that.
Person.
And then that just helped.
Okay, and who's the person? What's the name of the person?
That isn't a code
Item.
thing. I'm not sure.
Item dot income.
You should be able to continue going on.
Less than income classification threshold. Okay, now let's duplicate it for the high income. Note the idea here. We're restricting ourselves to the people for which this criterion is true, and we're taking the average over those people of this,
You can see this.
which gives the average amongst those individuals. Okay, let's duplicate it. Ready? Okay. Okay, there we go. Okay, there we go. Okay, among low income. Yeah. Okay, here we go. Now make it among high
I
income.
think. Oh, we got it. That was weird. Save them all. There we
Okay.
go. Save them. You've seen this event loop?
Yeah, I got that. All I did is I closed the properties window and reopened.
But it was like it kept generating them, like
Really?
30 in a
Yeah.
row.
Oh, did anyone else get an event loop exception?
That's an AnyLogic thing. That's not a code thing. There's something.
So what is the fix? Just go to what?
Just click OK.
30 times.
Until it stops coming. And yeah, I don't know what it is. So I might actually. So yeah, I just saved.
I would
it
be
all.
prophylactically, I would just save and close. And
That's what
come
I'm
back in.
suggesting. Is
Yeah.
So it's been saved now, and you know you still have to add this in, and that's where we're going to be.
Okay,
where it is.
so
I would restart AnyLogic.
okay, so ladies and
So we saved
gentlemen,
it
we
up.
added this among high
You see
income and
there's
low
no-
income.
there's no
Did you do
star
that?
anywhere. I mean,
Okay, now let's go add it to the graph.
Close
Can you add it to the graph for me? Win one for the Gipper.
Yeah, I did it a lot.
Yeah. Yeah. I've actually been seeing bugs on several people's computers. These like event loop execution errors or something, or like a slowness developing over time. Not that much time, a couple hours.
Yeah, but it was weird in that it popped up when I was just getting ready to type something. I wasn't doing anything.
Yeah, no, it's an AnyLogic
Okay,
thing.
so how are we going to add these to this graph? Can anyone tell me?
Go to the events
Sorry?
and stuff.
Yeah, okay, so we go there. No, we actually don't need the event at all. The event is fine, because we're not doing it to the histogram, we're just doing it to the prevalence of infection. So for the prevalence of infection, what are we going to do? add a data item, and this is going to be, instead of fractional prevalence of infection, it'll be fractional prevalence of infection among and
Double click.
amongst low income. Okay.
Betweenst.
Okay.
Belowst.
That's right. Okay. This dot population dot fractional prevalence among low income. Okay.
Is it this one? Your
And what I actually like to do
fractional prevalence of functional
is I actually, for the title, sometimes they'll put that over at the beginning, so I'll say low income fraction, so you can see it at first.
Sorry, I mean.
And next, I'll add another one for high income, right?
The low income statistic.
No, I didn't.
Okay,
Something can't be null, so this thing here.
okay,
Oh, that's interesting. Okay, I know it's causing it.
okay. High income fractional prevalence of infection. At Kurt's bidding, I'll delete the amongst. Okay,
Oh man, that is super frustrating.
okay.
So it's saying that you can't have nothing in here,
Yeah.
but you can't put anything in there because it keeps telling you.
Okay, among high income.
This is rather like arguing with a 3-year-old.
So we restarted AnyLogic,
Yeah.
and then because in the statistic there's nothing in the space that he was typing.
Yeah.
When he closed it, there was nothing there,
Mm.
and so
Because it left in that whacked out fashion.
Yeah.
so now we can't get back in. It's like blocked us completely. Like it just keeps just giving us this. No matter
Oh,
what
that's
we do,
interesting.
it just keeps generating it. We are
Oh.
permanently blocked out from this model.
Do you want a serious suggestion?
What's that?
Can I whisper it in your ear? Just go edit the ALP file and stick something in there.
Oh man.
Sounds like fun.
I told you I wanted to whisper it in your ear. Okay, so ladies and gentlemen,
It's okay, but none of us actually know how much of a pain that is or not.
yeah, it's
I've
actually
never done it before, so I don't know.
It's not done. It's pretty.
Yeah, I'd have to.
It's
find
a text
the right
file.
spot.
You can go on and put it.
What
So
was the name that we gave to the Histogram? It was
Where's
high
the,
income fractional
where's your
prevalence
the folder of your models?
Oh,
Where you
I did.
Well,
I actually did it like this. I put high income fractional prevalence infection and
Where
low
when you
income.
save them, where does it get saved?
And here we go.
That was the thing that was strange, because it goes to use
Okay, so this is what I get coming out of this.
unmatched.
You can notice the disparity
You don't have-
here.
When you go to documents.
The low income is much higher than the high income. What do you think that is?
Mhm.
So you can't actually, you can't go a little.
Is it more
bit.
connected?
They're much more connected,
So you
much more
don't-
heavily connected, crowded, in short, ladies and gentlemen, crowded.
And all my files, just a listing of everything.
And that's not to say they're always, much more. You can notice there's actually fluctuations. This is an agent-based model, but, it has stocks and flows conceptually going on. They just are not randomly mixed. And so there's actually these fluctuations. By and large, the low income has a much higher burden it suffers a much higher burden of infection than the low income. The low income, the high income suffers a lower burden of infection than the low income. Low income is worse off. Okay? Ladies and gentlemen. Okay. So, here we go. So we're going to now, so we've just added that, and that's notable because we're summarizing it over different subsets of the population in a very straightforward fashion in that statistic, right? In population, we're just saying for this segment of the population, the ones who are low income, summarize the prevalence. For this one, summarize the prevalence. And it's confining itself to that subset. Quite nice in my view. Okay, ladies and gentlemen, now we want to do something a little bit different. We're nearing closure with this. We want to go create a record of the number of times. So we want to go create a histogram of the number of times people have been infected.
Do you know the name of the folder?
How are we going to do that?
It doesn't show up.
A histogram indeed.
Folder list.
And what will we need to support that histogram?
Somewhere on its own.
What things will we need in order to print out the number of times they've been infected? How will we
Looked at it before.
capture that?
We went right click and then show model folder.
Yeah, it says users.
Yeah.
I can't.
We want to plot out for
This is
each
in users.
individual
This one here
the
is
number
in
of times they've been
users.
infected.
Yeah, it's not immediately in users. So
Data
here,
set to go with the histogram and then
this is
maybe
the
a
folder.
parameter
This is the
or
folder
person.
users Sean Kennedy document.
A
So
data
this
set
is
to go with the
users.
the histogram.
Where you download
Okay,
it to.
so how, for a given person, how do we remember how many times they've been infected before? We need a running count for them, right? The number of times been infected thus far. What does that sound like to you?
Variable.
A variable.
That's-
Oh,
So
there it
let's
is.
go to person
Okay.
and let's add a variable
SIR.
that is going to be
So I'm gonna go open with
count
other. Do you have a text editor?
of
Yeah.
times
Just like
infected.
simple text.
I'm sorry,
Note
Kurt.
or something. Note. Text edit.
You could,
I don't know. I'm not sure what it would be. What I would look for.
on Mac,
No, I'm in the file, but I'm trying to think of. the,
search for the name of the statistic.
Yeah. What was the name of the statistic? Do you remember? It was population. What was it? What are the statistics that are there? Population.
It was fractional prevalence among. Okay. Okay, so ladies and gentlemen, we have a variable. What sort of variable is this?
You start them off with the
Indeed.
population.
Indeed, ladies and gentlemen.
Nick, can I ask you something?
Yeah, but that.
So
that
before
was
when we
not-
were
but
counting
it was just
the
third.
incidents,
I'm
we
not even
were
sure if it's
in,
titled.
that was for the population, that's where we were in Maine, right?
For the whole population.
Okay, so that's.
Now we want to calculate on a per person basis and show it on a histogram across different people,
Okay.
the number of times they've been infected. And there's a method to the madness. We're going somewhere with this, okay? Are we ready? Ladies and gentlemen, initial value will be what?
Zero.
0.
It's gonna be-
Okay, when will this variable be incremented for someone?
Just the user list. Delete.
Irene may remember this
Just upload his-
from before.
It's possible.
That global variable, when did we increase that, Irene?
20 minutes just trying to find this.
And it was an event, right?
Well,
No.
remember we talked about 2 places we
The
could put it?
message.
Yeah, it's in this guy here. Remember that?
No.
Remember this?
Susceptible.
There's the plus plus. By the way, you could always do Control F and search for plus plus, and you could find it in places. That'd be another way to do it. But what do we need to do now here?
Was that you?
So, a mistake shot in infective, add like an extra action.
Or actually, we could just put it in the same place next to this one in infection. It's better to keep them together, right?
This,
Because it's a count of times infected. They're getting infected here. That's when they get infected. So what do we need to do here?
this.
This
count,
dot
something, count.
count of times infected plus plus. Right? Are we okay with that? Okay. Now, ladies and gentlemen, let us characterize the dysfunction curve. Okay. Okay, ladies and gentlemen, so we did that to person. How are we going to now summarize it in a histogram? Kurt, can you characterize the dysfunction?
Oh, who's this dysfunction?
Yes.
Because I don't know which statistic it was that we
Oh.
struggled on.
Do you want me to tell you?
The problem is I'm not sure if I'd even titled it yet.
Yeah, I'm not sure. I tried looking for the name of that statistic and it didn't seem to find it. So I'd just like to know any statistic that's on there so I can kind of look at.
Okay, there's one called fractional prevalence of infection.
I didn't see the word fractional present in that file.
Okay, so let me, pardon me while I assist. How about count susceptible? That'll be another
Count
statistic. Look for in-state, Kurt.
in state.
Or yeah, he didn't fill in the.
No, I don't see anything in state. Oh, this is the wrong population. That's the wrong model. SAR.
Okay. Okay. It's called SAR output or something like
These are
that.
just the ones I downloaded.
Kurt, it's called something like SIR output. Okay, ladies and gentlemen, how am I going to add a histogram for that? What do we need to do?
Wherever this was stored.
We need to add a
Histogram.
histogram and an accompanying what?
Data.
Yeah, histogram data. Okay, so let's go do it. Histogram data. Okay, this will be called count times infected histogram data.
In state.
Okay, good.
Um,
And now we're going to add a
fractional.
histogram. Oh, histogram.
Fractional prevalence. That one that is there.
Okay,
CD data.
and this is going to be a
It's not. That's the expression. Fractional prevalence expression type average expression.
this is going to be a
Count effective.
count times infected
I
histogram.
think it was a fractional prevalence. And so then what I need to do is just put in
You found it, Kurt?
I think so.
Okay. Count times infected histogram, and what do we have to do to associate it with the histogram data object?
Add
I might just copy.
Add histogram data, okay, and this will be count, this will be count times infected,
Let's see what happens now.
I'll say entire population, count times infected. Good. And then we'll have a then we'll have a count times infected histogram.
How come it's not showing up in the recent history? Oh, there it is. It's showing up.
There it is. Okay.
What are we adding to the histogram, sir?
Okay.
We're going to be adding for each person in the population the count of times they've been infected.
Right. Okay, so just add that. All I missed was adding that to the histogram.
We're going to add that to the histogram. But to do that, we need a what?
Population of agents. Something if it.
So Nick.
Yep.
Oh, so for the data, we're referring it to the histogram data object.
Changing.
Yep.
See that?
Yeah.
Okay, that makes sense.
And then what do we need to fill that histogram data object periodically?
I'm not sure
An event.
Which one? it
We
is.
need to add an
Really
event,
interesting.
ladies and gentlemen. An event.
Ah.
Okay. Ladies and gentlemen,
I've never seen this before in my life.
okay, characterize the dysfunction, Kurt.
The spinny color wheel of death.
Okay, I'm glad
Could
I'm
you-
not a back user.
Could you upload your version of the? Wow.
I didn't fill out a space fast enough of the thing. Committed hardy-kiri.
So Kurt, so
I-
this,
I put something in what I thought was the blank that this
Yeah.
the dog was complaining about,
Okay.
and it seems to it exhibits slightly less bad. Like it's not giving up an error every single second now. It's only
Yeah.
giving up an error when it tries to refresh the screen. So it's still highly problematic.
okay, well, I'd be glad to operate upon it, but I'd have to do so later. Do you want me to upload my model?
That would be quicker.
Okay,
Yeah.
so I'm going to have an event called populate count
I've never seen that before in all my years.
times infected histogram event.
Is it?
I-
Is there a way that you can force close it?
Yeah, I'm not getting comments from the peanut gallery because Kurt's better occupied. Okay.
Otherwise occupied.
Otherwise, okay. Populate count times infected histogram event. And what sort of event will this be? It'll be a timeout. It's going to go off periodically. It occurs cyclically, and it's going to occur once, ladies and gentlemen,
Go.
every week.
Ignore, I guess.
Once every week.
I-
Recurrence time 1 week.
Provide the application.
And what are we going to do in this event? Can anyone
This time
say?
we'll just, as soon as it opens up, close that model.
Histogram resets. Reset.
Good, we're gonna reset the history, that's great. Man, you are on top of things. This dot count times infected histogram data dot reset. Okay. Okay, and then I'll upload mine in just a second. I'm just getting to this logical chunk of work. And then what do I need to do over the population? Do a what?
So just
I'll give you a hint. It has an L, two O's, and a P.
Loop.
Yeah, okay. Okay, so we do a for, and what do I type?
Person.
Person, yeah, or we could call them person, lowercase person, or P. In the what? In the population, for each person, call them person in turn, what are we going to do? What are we going to do? We're going to add them to what? Add their what to what? Add to the histogram data their what? Their count, yes, their count of what? Okay. Count of times infected. Normally I would have called it count times infected. Okay. Okay?
Let's see if I can replicate that error on mine.
So I'll now go upload. Once I'm just making sure this is a happy camper. Okay, it's now happy. So I'm gonna upload it to the repository. Okay, here we go. And it is now uploaded. Should be able to find it there. It's called SIRS Output Model version 2. Okay, ladies and gentlemen, can we run this model?
Probably the Yep. Now you're caught up.
That was just bizarre.
Actually, I'd be interested if you send me that file to see if it dies on my version.
Ladies and gentlemen,
If it's like a permanently bugged one, you can send it to AnyLogic and be like, this is bugged. Yeah, here's a bug. Fix this, please.
ladies and gentlemen, yours is not a happy camper?
No.
Oh, okay. Kurt,
Try that. Do you know the?
Yeah, it's telling me it's that in that place. That's why I asked you.
So it says cannot convert from data set to histogram data, which implies to me that
maybe it's got a data set there instead.
so this is supposed to be a histogram. It's count times infected histogram data. Let's click on it.
Okay.
See here it's a data set.
Do you folks see something
So
like
it should
this
actually
one?
be a histogram data. So if I click on
Still
palette,
I've got some,
you drag the wrong one.
Sorry?
I've
That's
got some
pretty
problem. I'm not sure what.
histogram data.
Some
Okay.
syntax error.
Me too.
Oh, you got a syntax error?
Yeah.
Okay,
Yeah.
okay.
Now
Yeah,
what we're
wait,
going to do
action.
is we're going
Finger
to
on.
Okay,
all you need to do
let's go
is
check it
never
out.
anything.
Okay, so where is it?
Copy that.
Oh,
And then
okay, yeah, I don't see any obvious problem there. Oh, yeah, you need to, this is not a statement. You need to say, add it to the histogram data.
Happy camper.
Yeah. So,
Did you see hidden error or no?
Oh, no.
yeah, you're gonna, well, actually, you're gonna need to say like, number of times infected data. Yeah, but then you have to add this thing into it.
Yes, we can revise. Oh, by the way.
Times infected data dot
You
add,
should come to me for now.
and then add that person dot populate, because it's the number of times they've been infected.
That's right. Thank you.
Okay, who else needs help?
Oh, small p.
Person, this
Oh,
person.
it's a small person.
Oh, yeah.
The particular person.
Yeah.
Yeah, so.
Okay.
Make sure you're ending it with a bracket.
I'll try to stop by and ask her what
Yeah, yeah.
Did you separate
Depending on
the
what
top
machine
and
you're
bottom
talking
50% for the histogram?
I think so.
No, I didn't
Oh, sorry.
actually,
Yeah, I said bracket.
but, okay.
Do you say in the US, you say parentheses?
Yeah.
Yeah?
I mean, I think parentheses is more common than bracket,
Yeah.
or for the normal.
Aren't they different?
Yeah,
Yeah,
brackets are
exactly.
square
Exactly.
and parentheses are round.
Rounded.
Oh, not in quantum mechanics.
Is that right? Oh, bra and a cat. Yeah, well, that's got the greater than.
I always just say bracket. I sort of, it's the super class. They're all brackets. You
I
got
understand
curly
what you're
braces,
saying.
which
Yeah.
I guess are braces. I don't
Right.
know. They're all
Right.
brackets to me.
Right, right. Square bracket.
Yeah,
Folks say.
square bracket.
Yeah.
Or just normal bracket.
Yeah, they're kind of-
Parenthesis is just like, it's a hard word. It's a dumb word. Parenthesis. It's like rural. I try to avoid saying rural because it's a silly word in English. Anyway.
Okay.
Rural.
Yeah, I think the thing just hate you. It runs, but yours runs, but it doesn't show the plot the same way.
Sorry? It doesn't show
Oh, that plot is just a sample.
that's a sample
It's not
plot.
a real
It's,
one.
I think this is the plot you're gonna see up here.
Yeah. Yes, okay.
Same.
And as you run it, it gets more,
Yeah.
okay. Okay,
Of course. Martin's displaying a pathology.
okay. Ladies and gentlemen, now, I'm tempted to say, let's plot that histogram for low income versus high income people, but that would take some time. It would just require 2 more histograms, histogram datas.
No.
Well, okay, yeah, sure. Let's do that. It's actually really quick to do. Ready? Okay, take this histogram data object,
Done, recovered.
and I'd like you to copy it twice. So copy it, and then I'd like you to paste it, paste it once, and paste it twice. Okay? Okay? Paste it once, paste it twice. So ladies and gentlemen, I've just taken this histogram data object and I pasted it 2 times here. Okay? And the first time we paste it, it'll be count times, we'll just leave the first one the same. The second one will be histogram data low income. And the third one will be histogram data will be high income. Okay? Otherwise, we leave them the same. Now, for this count times infected, ladies and gentlemen, we are going to go add in histogram data, and we'll make it low income. We'll see here we did title entire population count times infected. Now we'll do low income count times infected, and this is going to be count times infected low income. Here, the histogram. Next, we'll do the same thing for high income. Okay? This will be high income and now we'll do count times infected high income. Okay?
Yes.
Okay, now, I'm not even sure we need the first one. Like, why have a histogram for the entire population if we have 2 for each of the subgroups? What do you think? Let's delete the first of them. Let's delete this one at the top, because it may actually hide the others, is another one of my secret fears. Okay? So now we have 2, high income and low income. Are we ready to do them? Ladies and gentlemen? And so we can actually get rid of this. We don't, sorry, the histogram data by itself. We just need the low income and high income variants of it. Are you ready for that? You'll notice it's going to show up in different colors here. See that? High income and low income. Are we ready? So I got rid of this one, and I just have the low income and high income ones. Are we ready for that? Okay, ladies and gentlemen, let's go to the event now. How does the event need to be changed? Right now, we just have it populating this data. How does it need to change?
You gotta include low and high income.
Yeah, so we're gonna need, because we're putting more than one statement inside it, we need these brackets, these curly brackets around it. What might be called braces, right? In this, because we're going to put more than one statement. And what statement, actually, truly speaking, we actually don't need it, but it's good to do it, because it's actually technically not going to be more than one statement. But what is, yes?
Sorry, when you have removed the data for the histogram, then you have in the code, don't you still have that?
Yeah, and so we're going to have to change
Oh, okay,
this.
so that's where you're, okay.
That's where I'm going. Okay, so what are we going to do? If we have only these two, what do we need to test here?
If the income is more than 500 or less.
Yes, okay. If, whose income? Person dot income. Think of that dot, it's almost like an apostrophe S. It's like their income, right? Person's income is, if it's less than, what do we call it? The income classification threshold. Then to which do we add it?
To the low.
To the low. Okay, count times affected low income. Otherwise, count times affected high income. Okay, let me put it up, ladies and gentlemen, on the big screen. Bearing in mind that this thing has only changed, none of this stuff here has changed. It's only I've added these brackets, and then I've said if person.income is less than the income classification threshold. And the reason, ladies and gentlemen, I was able to do that reasonably quickly, especially quickly, is I used autocomplete. And I don't have to type these long names. Okay? So if it's less than that, then we add them to the low income. Otherwise, we add them to high income. Does that make sense? Can we build it?
Do you need to delete the first
Oh.
sentence?
Oh, you know what? Sorry, we need to have reset. Thank you. Reset. What things do we need to reset at first?
The low and the high?
At both of them. Exactly. So I'm sort of consolidating. So I stand corrected. We actually need to have this up there too. Reset. Oops. Reset both of these. Do we need semicolons after them? You bet we do, because they're commands. They're saying reset this, change this thing. Right, Kurt?
Yeah.
Okay. Okay.
Just blow it up and leave it up for a second.
Yeah. Yeah. Here we are. Remember, autocomplete is your friend.
I might want to mention you're a lot faster on that keyboard than most people in this room. Adding things and changing things and controlling arrows and stuff.
And typing long sentences.
Well, part of it is because it uses autocomplete.
Even for
Great.
low income amongst blah 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 blah.
Yeah, I mean, once you name it, then it'll autocomplete for that.
Well, but even for naming it, I'm like, count, and he's like, done.
Right.
Yeah. That's my problem.
It's also a skill of, they call that camel case. You see where it starts off with a small letter, and then every new word is a big letter. There's no spaces. So that's a common naming convention, because you're not allowed to put spaces in names. And so sometimes another convention is to put underscores or underbars in between words, but that takes more time and the names are longer. So camel case is a common one. It actually takes skill to learn how to type words without putting spaces in between. So part of that is also the number of years he has spent typing in camel case.
Yeah. And Ned's going to be dealing with a different sort of camel case.
Is that a literal camel?
Literally.
Yeah,
Yeah.
a case of infection.
Yeah, the
MERS.
camel case instead of a human case.
Yeah.
This is a camel's case.
Yeah.
Good one.
Yeah. So it would be fitting if in the School of Veterinary Medicine, College of Veterinary Medicine, they use camel case.
Yeah,
Yes,
it would be fitting, except it'd be difficult.
Right.
And,
Yeah. So these are the same basically, except one is high income, one is low income.
no income add.
Yeah, low income, add person count times infected. Yeah. And so you just copy that line. That whole line, you copy it.
Oh, it's just this one.
Just that one line, yeah. Copy that.
Do you want to run that thing, folks? If you run it, you should see something.
And then
What do you see?
enter. Yeah, except you're gonna want to have, so press enter.
Oh, there we go. Back to that.
Okay.
I wanna see it. What do you see? I don't mean the code. What do you see on your screens?
And then we need to put an else statement in there. Yeah, and then now all we need to do is this first up here, so this you can.
You need an end curly bracket.
You want this
Mind you,
one-
AnyLogic is
like
very
high
sensitive.
reset.
Make sure you have the right number of end curly brackets. It will get horribly confused if you have curly brackets that don't end or have too many that end.
Open and close paren.
Yeah, and I think.
And then you can delete the rest of that one.
It's showing.
Open close, open close. Yeah, and then delete.
That just means call it without giving it
No,
anything.
that makes sense.
So you have one too many closed brackets. Two closed brackets. There you go.
Yeah.
So you first reset the low income one, then you reset the high income one. And then you go through for each person.
Low income
And you say if that person,
Okay.
if that person's income is less than this.
Okay. What patterns do you
should be a closed
see among this?
then
which
if it's
population
less
is
than that,
harder
then you
hit?
have this low income
Low
unit.
Low income.
And if it's greater than that,
It's
or other
shifted
than
up
that,
here
then
to
you
the
have
right.
this.
There's quite a few high income that are not infected at all. And of those who are infected,
Maybe build it.
even of those that are infected, they tend to be infected with
Okay.
less,
And that-
fewer times.
Count
than
times infected.
Now,
Histogram.
it's notable that we could now formulate, if we wanted to, an intervention that would focus on people who have a high numbers of past times infected, the frequent flyers, for example, and focus on them. We could do it based on their history. We could do it based on their network position, how many people they are connected.
Yes.
We're going to have one final graph, okay? Ladies and gentlemen, I'm showing you one more analytic tool that we found of exquisitely valuable. And this will be a plot.
The other one is times infected high income. And so the difference here is that this one doesn't have the word data in it. So
Okay, so Kurt, I'm adding a scatter plot,
This one doesn't. I didn't put it in there.
and I'd like to add a data set. And this will be called, and Kurt probably won't like this, income versus infection count
data, high income.
scatter plot data,
Variable. Did I do something wrong here?
data set.
Dot.
Yeah.
Okay, that's better.
Okay, income versus infection count scatter plot
The,
data set.
data.
And now I'm going to name the scatter plot itself.
Income
I'm going to call it
That's not a function.
income versus infection count scatter plot. Okay? I'll put the name up on the big
It's
screen
just a
in case
double, so it's not a
you want to
function.
see what I'm saying, because it's a mouthful.
So here I'm treating it as a function because I'm doing opening.
Here we go, like that.
parentheses. You just do like that.
Like that, ladies and gentlemen. Okay?
Resolve to a variable, and that's just because.
And then the other one's scatter plot. Okay, what do you think the scatter plot needs to do to work? To what must it refer? Yeah, it has to refer to the data. I think you should see a general pattern of this. Often we have charts, and the charts have to refer to the corresponding data item.
You pulled a time plot, is that right?
It's scatter plot.
Scatterplot.
Kurt, its name is, should you care to accept it, its name is income versus infection count scatter plot. Income versus infection count scatter plot data set.
That's the data set.
That's the data set, and then there's the
goodness.
scatter plot. Yeah, I know. I told them you wouldn't like it.
Income, what is it? Income versus infection count.
Yeah.
Scatter plot. Scatter plot.
Data set.
Data set.
Okay, now that's a regular data set, Kurt.
Uh-huh.
Now, we're going to frob it in just a minute. Okay, so what is this scatter plot needs to refer to the data set, does it not? Okay, so now we'll have income versus infection count will be the title. And ladies and gentlemen,
So the title, income versus infection.
we're going to make this depend. This is critical. This is critical. This scatter plot data item is going to depend on a data set. Okay? The data set of which Kurt does not wish to utter its name.
The name. This is the Voldemort data set.
Right. You dare not utter its name. So income versus infection count scatter plot data set is what this will be based on. Okay?
Got it.
Now, ladies and gentlemen,
Yeah.
the other thing we have to do, and I want people to pay attention because this part is easily missed.
I might just
We have to go to the data set itself,
income versus.
and we have to frob one thing here.
Infection.
Okay? Actually, two things. So I'd like you to help me frob these things. Keep 1,000 latest samples.
Oh, you can just do infection.
And secondly, uncheck the box that says use
Scroll up.
time as horizontal
Scroll up with you.
value. Uncheck this.
You have to use your scrolling feature.
Oh, I didn't know where you wanted me to scroll to.
Yeah. So let me scroll down. This is the. Oh, this is the data set. Sorry.
It's the data set.
I got confused. Click on the data set. So
Yeah.
you want 1,000.
And Kurt, he's going to need to frob two items. He's going to uncheck use time, and he's going to have to keep 1,000 samples.
Uncheck use time. So
Yeah.
you don't want time
Okay.
on the axis.
Okay,
You're gonna
ladies and gentlemen.
infection.
Okay, so now we are going to drag in an event. One more event for the Gipper.
Well,
Okay.
that Kipper has a lot of events.
I don't even know what that means.
One might call him evented.
It's an American film reference, which is the funny thing.
It's an old American film reference. I actually don't know what it is. I'm gonna Google it.
Okay. So this is going to be called income versus infection count scatter plot event. Okay, when you're building your own models, you can name it whatever you want. Just remember that if you name it too short, you won't remember easily what it is. Okay, so this is going to be a timeout, and it's going to be cyclic. It actually played a prominent role in a previous U.S. election.
I was
Actually,
gonna
two of
say,
them.
yeah, the
Two of
origin
them.
here is actually it's a quotation from Ronald Reagan.
No, it's actually not. It's a quotation from a movie that he played in.
Yeah.
Played the part of Gip in the
Yeah,
1940 film
yeah.
Newt Rockney, All American, which is a football movie from the 1940s.
It's the most obscure word.
Yeah.
Okay, so I use it in Australia, and yeah, it gets puzzled looks. So this should be updated, ladies and gentlemen, every month, once a month. On the other hand, my Australian colleagues take great delight in trying to get me to use a local Australian euphemism for zero, which to me sounds of questionable propriety. But they tried to get me to do that. It's on a recording.
I'm not sure what
What
this
note?
word is, so it's hard for me to judge its
I'm looking at it.
hilarity.
So zero has a special term in Australian lingo,
Uh-huh.
and
Does anyone here know?
That's right.
Australian? Norse? What do you?
no, they said I should call zero when in my boot camps. I should call zero, and if I use Australian boot camps, I should call it bugger all.
Bugger all. Zero, they say. It's nothing.
Yeah, bugger. That's, yeah, knowing the true meaning of the word bugger is maybe.
Well, I'm not sure. And I
That's-
asked
that's
them, this
trepidation.
doesn't sound proper. I said, will your grandmother be okay? And they said, yeah.
Yeah.
Then one of
absolutely,
the,
that'd be fine.
My dead grandmother wouldn't do that.
And it's a bit like saying bugger off, right? Which is like go away.
But it's not like that because that would have like a you're annoyed at that person. Where bugger all's like nothing.
Yeah.
It's like my grandma would be
But the
fine.
word bugger
It's terrible.
has a certain specific meaning.
It's it's not a good
that
word.
isn't a positive one.
But no one thinks about that before.
Right, right.
Yeah.
I do. That's the problem.
Okay, so, well, that's the problem when you
Right, right.
using it. Yeah, they feel uncomfortable and they laugh at it. Okay, so ladies and gentlemen, so what are we going to do in this event? Right now, the event contains, well, you can use your own term for it, and the action. There's nothing there right now. So what do we need to put in the action? What does it need to do? By the same token of what we did for the previous event.
I call the plots. I mean,
Okay, yeah, but this event needs to do what?
First, probably reset something.
It probably resets, so income versus infection data set, it needs to reset that. And then what does it need to do? I'll give you 2 hints, or I'll give you a hint. It has an L, 2 O's, and a P. So what does it need to do?
Four.
So what do I need to type?
Four.
For what?
Brackets. Person, person.
Yeah, person,
Points.
colon, this dot population, or just population, yeah? Okay, so for that person, what do we need to add their data? To the this dot income versus infection scatterplot data set. We need to add it into the data set. And what do we need to add? Well, it's an income versus infection count. So we need to add first their what? It will be reversed in physics, but first what do we need to add for their X value? Think about the name. Income versus infection count. The X value should be what? Income. So whose income? Person's income. Person dot income is the first one. And then what? Person dot what? Yeah, the count of times they were infected. Are we okay with that? I don't know how you named it. I count of times infected. This is what it is. Are you ready? Okay.
I had no idea that President Reagan was an actor.
Not a very good one.
Before he was, it said here that he had a job with General Electric Theater that earned him $125,000 a year
wow.
at that time, which is over $1 million in 2010
Wow.
dollars.
That's good.
Yeah, so
He and Schwarzenegger were both governors of California's
that's
actors.
interesting.
Huh.
Yeah.
That's interesting. Schwarzenegger will be unable to complete that match, though, given his birthright.
Okay, should we run it? It should build. Okay? Okay. Oh gosh. Okay, so sorry, I'm okay. Oh gosh, that looks horrible. So we don't want to do that. Sorry. So we want to. I'm sorry, I forgot one critical thing. What did I forget? Does anyone remember? Scroll down on this chart, on this scatter plot, and you need to uncheck draw a line. Can you do that? Can you do that? Draw a line
To make it a scatter plot.
to make it a scatter plot. Can you do that? So you go to the scatter plot and you scroll down. We should have known because it had lines on it, on the static image, but
Yeah.
you go down and you go to draw a line. It's in the, ladies and gentlemen, it's in the appearance section. So you may have to expand appearance. Are you ready? Okay, ladies and gentlemen. So we're going to run this. What do you see here in terms of this scatter plot?
The scale is messed up.
Well, yeah, it's a log normal distribution, so there's some people with very high incomes. Let's confine it to between 0 and 5,000. Okay? How are we going to do that? Where would we look to confine it? The scale of what?
Horizontal scale.
Okay, in the data set or in the in the plot itself? I think there's a scale, and we could say very good, man, you folks are good. For the scatter plot itself, for the scale, to be honest, I couldn't remember which one I was in. So go to the go to fixed here. Yeah, I forget which one.
I do too.
Go to 0 to 5,000. Okay. We don't need those gippers on the far right.
There's only one Gipper. The Gipper.
I know, he's way out there on the right.
Yeah.
Right?
I guess. I don't know if he was at the time. He was an actor at the time. So maybe he wasn't at the time.
It was after. It was about a football team in the 20s.
It was about a football team in the 20s, and he acted in it in the 40s instead.
Yeah.
And then it became an expression, the U.S. Like,
Well, that became his nickname until he died for the Gipper. Went for the Gipper.
Right.
It's about a football guy who was dying, and he basically was like his dying wish to the team, like, you know, when it starts getting hard and stuff, like, we'll win one for the Gipper. And everyone liked him, but he was dying, and so they got the sort of motivation to win the game, I guess.
Yeah. Okay, so ladies and gentlemen, here's our scatter plot. Here's our scatter plot. This is plotting income on this x-axis and infection count on the other. Now, this is an example of an association of which I spoke this morning. You have on the one hand some negative association between infection count on the one hand, income on the one hand and infection count on another. Now, had we time, and unfortunately we don't, it would probably require about 15 minutes or so, we could put in place an intervention that would focus on people who are, for example, who have high numbers of previous infections, the frequent flyers, and we could focus on reducing their susceptibility. Or we could focus on people who have large number of connections, and we could focus on faster recovery for them. Something along those lines. And what you would see is that this curve, this association on the one hand between income and infection count would be shifted. You might see a rather different curve that results from that infection because we've changed the underlying nature of the data generating process. This association is coming from some process in the model that's simulating infections. People at low incomes have larger number of connections. They're more crowded, therefore it tends to spread more. They're more likely to get reinfected after becoming susceptible again. Therefore, they have higher numbers of times infected, and they're going to tend to have a larger number of times infected as the income goes down. But this association would change with interventions. And this is one of the reasons why a statistical model that was purely taking into account this statistical relationship between the two might be a very good and very insightful description of the current situation that obtains right now. But in the context of an intervention, that statistical relationship may not hold because we have altered the system that gave rise to it. We have put in place an intervention that changes vulnerability or that lowers contact or that enhances recovery, and therefore it would change the shape of this curve. And there are models where I've run which has done exactly that. And in fact, Kurt could show a little example. Kurt, do you want to show some examples of those graphs from that other model?
The
dental health model?
Sure.
Sure?
Yeah. Sure.
Because what I've tried to do here is I've tried to build some skills on your part for common mechanisms. And these started very modest, right? You may remember the first one we did was this one. Very simple. We defined each slice of the pie and specified a counter. And we could do that with things purely in the the statistics area, the cross-sectional statistics. Something like this, we also defined a cross-sectional statistic for, and we applied it to different subsets of the population, right? You remember that? We actually defined within our model here, we defined here in our model statistics, statistics that applied to different subsets of the population. Remember this? Fractional prevalence among low income, high income. And that could give us some sense as to the underlying patterns and where is infection being felt in the population, where's the burden. Mind you, in our population, we have income as a continuous quantity, but it was useful for the purposes of illustration to summarize it in a stratified way. So high-income individuals had lower fraction of infection, and low-income higher fraction, this green one, and then the yellow, the midpoint. Right? So that was another sort of graph that we could create very readily using built-in statistics. Now, this histogram here was a one-time histogram we created to display the distribution of incomes in the population, right? And we used it to display a breakdown and the upper and lower 50% of the population here. This income, this one up here, count of times infected, this required a specification of, for each individual, a record of their longitudinal history, the number of times they've been infected. In one of the other models that I've given you, we actually record not only count of times, say someone has become a cigarette smoker, but the total length of time, the accumulated length of time, the pack years smoked, for example. And in fact, that would only take about 5 to 10 minutes to do if we wanted to accumulate the amount of time cumulatively that they've been infected. Very straightforward. We further, however, looked at this one here, which was the scatter plot. And these scatter plots are particularly insightful in an individual-based model because each dot here represents a person, right? A person's characteristics, their income versus their infection count. And there's often a story that emerges from these things about different types of individuals, how they have different outcomes over the attributes shown here. And scatter plots like this, being based on the synthetic population in the model, can often be quite insightful as to giving you a sense about what's going on in the model in a really fruitful fashion. Now, the final thing we added, and I'm surprised I haven't seen it here, maybe we didn't create a graph of it, was the information on, where is that? Oh, incident case count, this one right here. This incident case count, the number of cases over time. We showed how we actually can plot it here. So you'll notice in this little window, if I go there, I can plot it out. And I can also copy it. Copy, and I can go paste it in here to Excel. This is the incident case count. This required also, just like the number of times, recording the number of times someone's been infected, it also required recording the, having a variable that counts up the number of infections that have occurred over time. Do you remember that? Okay. So very, very fruitful way of looking at these things. Kurt, do you want to show something here?
I can show some things, but yeah, I mean, this is a bit of a case study, but
yeah.
I don't see it taking more than 15 minutes or 10 minutes.
Absolutely. Let me, maybe before, just while you get set up to do that, I will go up to our class area here, and I will give you, or I will show you a interesting model that we've been working on with, oh gosh, I'd like to show that to you. And it's a newer version of AnyLogic that was used. Beware backwards compatibility. AnyLogic, well, okay. May I show you how AnyLogic encodes files under the surface? Yeah, you know where I'm going.
Is that
You bet I'm going. Yeah, you bet it is. Okay. I'm not going to let that stop me. Okay. So, ladies and gentlemen, this is what an AnyLogic model looks like behind the scenes. And I am actually going to go open this model that I wish to open. Okay. And you will actually see that AnyLogic models are encoded in something called XML. XML is a textual representation format, and you'll notice that there's documentation on the model in here and information on different types of dimensions used, etc. Now, there's also a reference to the AnyLogic version that was used to create it. And the ALP version similarly. And I'm just going to change this temporarily to be an earlier version because I want to be able to open this model. And I will call this pertussis ABM hacked. Hacked. Okay. Okay. So I've just done that. Now let's see if we can open the model. Here we go. That looks good. In general, don't open things that are called hacked. But okay, let's see if it can open it. It's not clear to me that
unless you're the one that hacked it, then.
Okay.
No
Okay, ladies and gentlemen. So here's another example of a model that's designed to show information on statistics on a model. So here, for example, we have graphs of by vaccine attitudes, and this is endogenous influenza infections versus exogenous, those from outside, the fraction of people who are in different states, infective, etc. We have infection by, I think this is by age distribution, exogenous and endogenous infection by age. And we have a way of configuring the model to set off interventions at certain times. Monthly accumulated incidence rate, yearly accumulated, summarized, in other words, incident cases in different ways. And we have over here a variety of outputs that are textual in nature, reporting on things like the average age of infection, the lifespan in years, reporting interval, contact rate, initial population size. Basically, some of these are assumptions to use in the model, but a lot of them are outputs. And when we run the model, we'll summarize information across many of these graphs at the same time to have sort of a command center view for what's happening here. And as a result, even though it slices and dices model data in different ways, you can often get a much better sense of what's going on in the underlying model by having this sort of suite of different outputs that you can look at. This is a model that's quite rich. It has a population size of 500,000 or 750,000. We have to be careful because that's a large size. But we stratified it in various ways. And that's exactly the point, or one of the big points, that models articulate at an individual level where people have continuous ages. You can capture a continuous age very readily here. We can summarize them, slice and dice the numbers in different ways to summarize people according to one set of attributes or another in these different graphs. Kurt, do you want to show yours right now?
Sure.
Okay. So, do you want me to unplug this?
When I borrow your adapter.
Oh, the adapter? Sure. Sure. There you go.
Gracias.
Okay, very good. And maybe you could run yours if you'd like to.
It is already run.
Okay.
So maybe I'll just do a quick overview just so you can kind of see its context. There's a lot of little details in there, but its main information is captured in just a sort of a few state charts. So